and answer some few questions and talk a little bit about the stuff that's going on in space. All right. Hello. Hello, Kenji. Hello, Anton. Let me think. There we go. So yeah, so today we're going to be, at least start to try the new NASA Space Shuttle set, the Discovery set. I don't think we'll be able to finish it today, but you never know. We'll see how far we can get. Ugh. Hello. Yeah, but this is my first attempt at live streaming, so if it's noisy or something doesn't work, please let me know. I'll turn down the music just a little bit. Maybe that's a little bit better. I already dropped one bag. So yeah, the Space Shuttle Discovery set from the back here. Let's see how much we can get here. Includes a mock-up of Hubble and Space Shuttle Discovery, obviously. Yeah. So who knows how much we'll get done today. But it should be interesting. I think most of these bags are the higher numbers. Yeah, 11, 12, 10. These are some of the larger pieces. 6 or 9. Let's see. Hello. Oh, looking the wrong way. Here we go. Nice to know, Anton. I don't know how long this is going to take, but I don't think it'll be finished today, especially in the few hours that I'm streaming here. Still have not found the instruction manual yet. It's very important. 4, 2, we're getting closer to the beginning. There we go. Three. There's number 1. I imagine that's probably going to be the sign, the nameplate for the shuttle. 7, 8. Yeah, we won't need any of those anytime soon. 5. Yeah. Okay. A lot of these are just ones we'll be needing later on. But we will be needing this. Let's go ahead and put some of these larger numbers to the side. Yes, this is the Discovery set. Most recent one. Oh, I guess one of the more recent ones that LEGO has released. I have built the International Space Station set, which also has recently come out, and that one was a lot of fun as well. There's still some others, like the Lunar Lander and the Saturn V, which maybe one day I'll get to building, but this one is the next one up. Alright, so let's open up the instructions and the stickers. I hope you can see that. There's the shuttle. Hubble. Some information about Discovery and Hubble. There we go. That should be a little bit better. Probably won't be needing all of these today, but some of them we might. Here again is the box before we start putting some of this together. I think probably the first steps will be building these down here. See that? There you go. These nameplates. We have a tray here to make it a little bit easier to see what exactly pieces I'm working with. I think there should only be one bag number one. Yep. So just like I was saying, these first ones we're going to be using to build Hubble. 1, 2, and 3. There you go. No, definitely not IKEA instructions. These were IKEA instructions. I'd have to skip every 15 pages or so. And then, yep, so then these ones we start getting into the base of the shuttle. Yep, Hubble did come back to life. There was a scare with one of the computers. I think it was in June, or maybe it was late May even. Worried about one of the computers, and they had to switch to the backup computer. But they were able to restore it. I mean, Hubble is, let's see if it says here, it might not. But Hubble's been operating for a long time, and hopefully soon James Webb will be able to be launched and get its way out into the Sun-Earth L2 point, and once it makes its way there, it'll be able to give us a lot more information about the universe. But for the time being, Hubble is still one of our main contributors to astrophysics. All right, so I guess we just go ahead and get started. Yeah, I'm not sure. I think Hubble is a collaboration between a few different NASA centers and the European Space Agency. I think it might actually be operated out of Goddard Space Flight Center. Hope you guys can see that. Yeah. All right. Yep, so first we're building just this little nameplate for Hubble. Oh, but I think that's actually the whole nameplate. That was quick. Let's see which way does it want it to sit there. Yep. So yeah, Hubble would be, actually it's 31 years old according to this sticker. It was launched on April 24th, 1990. Has a velocity of 4.72 miles per second. See if you guys can see that. Wonder what that is in kilometers per second. Yep, deploy altitude 350 miles. So it's only in low Earth orbit. That's a big difference between Hubble and James Webb. But we still have learned a lot from our friend Hubble. Ooh, we got a couple questions. Hello, Nin with the bin. Hope I said that correctly. And when will we be landing on Mars? That's a good question. I guess there's a big kind of like asterisk there. You know, when will humans be landing on Mars, or when will the next missions be landing on Mars? Technically the next window for Mars isn't going to be until next year sometime when we can launch, due to the relative oh, thank you, 563 kilometers above sea level. So yeah, that's where Hubble is currently orbiting at. 2026 at the earliest. Yeah, so if you're talking about human landings, then really you have to be looking at the different types of vehicles that are available. And I think the biggest one that people would probably think with landing humans on Mars right now would be Starship. Now, with that being said, NASA is pursuing the sending people to the moon through Artemis and then eventually getting to Mars. Yeah, so human landing. Oh, they didn't switch the units to metric. Yeah, so it's all in miles or miles per second or pounds. Yeah, that's unfortunate. But no, yeah. So so in terms of NASA landing people on Mars, I don't know if they have explicitly said when they're going to be sending humans or astronauts. I guess that should be the point. I know there's been a lot of focus right now, at least in the Artemis program, which for the meantime is sending people back to the moon and then eventually understanding how we can go to Mars. But another approach that a lot of people are interested in is what Starship will be capable of doing. Now, I think this comes a lot on what SpaceX is currently developing and what they'll be working on for the next, 3 or 4 years or so, especially focusing on the Human Landing System, or HLS, for NASA, and sending people back to the moon. But also some of that technology can also be used for sending people to Mars, or at least landing first cargo on Mars and then eventually crew. I know back in 2018, I think I created a video about SpaceX's timeline, and back then during one of Elon Musk's presentations at the time, which was the Big Falcon rocket, or BFR, he claimed that it would be until 2024 when I think the first humans would land on Mars. But that still might be a little bit of a tough time frame with the development of HLS and Starship, or I guess Starship now, which was BFR. So there's a lot to say there. Yes, the next mission should be the European Space Agency's. I think it's the Rosalind Franklin rover. I can look that up really quickly. I believe it was supposed to launch actually this past year, but due to some challenges, they had to postpone it to the up-and-coming launch window. It's scheduled to be September of 2022. So that's when the next launch window should be opening up for a transfer to Mars. Let's see. I think SpaceX will need to make EVA suits for the Martian condition, so it might take a while. That is a good point. So going to Mars is, a lot bigger of a challenge than providing the infrastructure or the vehicles to get there. I think that there's still a lot more that needs to be developed in terms of how we're going to keep astronauts safe for the, I believe it's 8 to 9 month journey to get from Earth to Mars, especially when we get to the surface. How are we going to reduce radiation exposure? Do we plan on bringing astronauts back? There's a lot of questions that go with how exactly we send humans to the surface of Mars. So I think it's, even though Starship can definitely help, or lowering the cost to get to space can be pretty important in terms of allowing us to explore space and get to various locations. At the end of the day, we have to be able to maintain the astronauts, make sure that everyone is as safe as they can be, or at least when we get there, have a place for them to live and food to eat and so on and so forth. So Mars is a very big challenge. Very big challenge. To be honest, the faith is only in SpaceX will pull it off quicker. The human landing on Mars. That's a good point. So SpaceX definitely, and I think they are very passionate about going to Mars. If that's probably their main goal. I mean, obviously, is to eventually colonize the red planet. But it's definitely, I think it's definitely going to be a group effort. It's just like many other challenges, just like Artemis. I mean, it does require, at least for now, does require a pretty extensive. Oh, I didn't want to skip that step. Pretty extensive. What's the word? Collaboration between different groups and different agencies or companies. So even to go to Mars, which is something that we've never done before, is something that will also require a lot of collaboration between, whether it be different commercial spaceflight companies, space agencies, whether it be in the United States or international efforts. It'll be difficult. I feel like it's going to get delayed by a decade or possibly more. If that's referring to human landing on Mars, then it could potentially be in the 2030s. Who knows what could happen in the next few years, to be quite honest, in terms of the development of Starship. Let's see. I would love to see a Starship Lego set. I too would love to see a Starship Lego set. I think that would be pretty fascinating. I mean, I think alone, I would love to see almost any space mission be a Lego set, because that would be awesome to be able to recreate or build a lot of the same things that NASA or other space agencies or companies have been able to work on. But it'd be really neat to see a Starship. I imagine that'd be a pretty massive set, probably on the scale of maybe a Saturn V or something of that sort. China plans to send its first crewed mission to Mars in 2033. I guess there's a lot of regulatory and ethical processes for a private company to land humans on Mars. Yeah, I know at least there's been a lot of claims as to when future Mars missions could be. For the United Arab Emirates that recently flew the Hope mission to the Red Planet, they also had a timeline. I can't remember exactly what it was, but they also had a timeline to when they would eventually want to be testing. At least I think recently they might actually be doing simulated Mars habitats here on Earth to just keep people in isolated conditions to test different components of how they would react on Mars. But in terms of the long stream, actually sending people there and having the resources to maintain a presence on the red planet is difficult. So who knows? I think for a lot of space exploration, once the estimates for things get into the decades or get in beyond 10 years, it's really hard to know how well or how quickly some of the technology will progress. But yeah, so far we're building this. We already finished the little one, and we're working on this larger stand for the Space Shuttle logo, which is fun. Still on the first bag. But yeah, nonetheless, it should be very exciting to see what all is able to be developed in terms of Starship, in terms of up-and-coming Artemis missions. There's a lot that's happening, so it'll be exciting to see and follow everything that's being worked on. So there's a little fun fact in here that says, did you know that the idea for Hubble was first conceived in the 1940s, or I imagine at least a space telescope was conceived in the 1940s, since that was before any satellite had reached orbit. The Hubble Space Telescope took decades of planning before its first launch in 1990. So even though it took decades of planning and getting it up there and having the success that it's had, it's very relatable to James Webb, which too has taken decades of development, testing, improvements, and so on and so forth, just to make sure that all the systems are ready in the hardware, which in of itself will be very impressive once it gets to the Sun-Earth L2 point. Nin with a bin again says there will need to be a lot more technology made in order for us to send people to Mars. Yes, so we've shown that we can send people, or we can send robotic missions to Mars, I guess. And in terms of landing robots safely on Mars, NASA's gotten fairly effective at doing so. They've been pretty successful almost the last 2 decades or so with sending robots to the surface of Mars. But just like sending people to the moon, it's a very challenging ordeal and takes a lot of effort from a lot of different groups. And actually I guess this is a self-plug almost, but in the video I just released earlier this morning, I talk about a lot of the accomplishments in the early days of NASA, the first 20 years. And you notice that a lot of these programs that went into Apollo, they also helped understand, the larger scale of exploring the moon, whether it was sending missions to fly by the moon, whether it was trying to impact the moon or orbit the moon. These were concepts that in the 60s or even the late 50s or early 60s, we really didn't know how to operate a spacecraft to do these things. So it really was a group effort across all of NASA or most of NASA, I should say, because there were other programs that focused on various disciplines. But it really was a group effort from across the agency to get people onto the surface of the moon by the end of the 1960s. And I think just like now, which there's a large collaboration to get people back to the moon and get to the moon sustainably through Artemis, there will also need to be a very large collaboration to get people to Mars, because Mars in of itself has a lot of challenges, just in terms of the duration of missions, how long it takes to get there, the type of resources that need to be available. There are a lot of difficulties. Let's see. Elon wants to move fast because he's not getting any younger. Yeah, that's a good point. Milky Away. I like that name, Milky Away. Yeah, I mean, I think since SpaceX and Elon definitely are really driven by getting people, or creating a multiplanetary or making humanity a multiplanetary species, and that is not an easy task. And if Elon really wants to see people land on the surface of Mars in his lifetime, then he's definitely pushing for it. It's really a good aspect of it. Let's see. The major concern is sterile vehicles. Everything else can be dealt with by implementation of regulations and laws regarding conduct. Contamination is really the most important issue. That's a very good point, Heat Shield. Also a very good name. Liking these space-themed names. So, in terms of contamination, and this is really something that has been not necessarily debated so much, but a very interesting topic is, how well do we need to make sure that we aren't contaminating Mars? Many of the missions that we send to the Red Planet, even today and for the last few decades, have focused on just determining whether or not Mars could have once supported life, or even if they could have once supported life, did they support life? Through, Perseverance rover, Curiosity, even going all the way back to Viking. Astrobiology has been a very important part of the exploration of Mars. So the big point about that is, how do we oh, I forgot to open this bag. Yep. So how do we not necessarily prepare for, but how do we know that what we're sending to Mars will be, what's a good word for it? Not contaminable, so not having, man, I'm losing track. I lost my train of thought. Essentially just having the knowledge that, we're not going to contaminate Mars, such that if there was life, then we could never detect it because we just found our own. Which means that in terms of larger vehicles like Starship, which currently are built outside, even though they're, it will be developed and will be improved, sending something that could contaminate Mars could be a major challenge. And that's something that's currently argued. Some people claim that, that's a risk we're willing to take if we want to send people to the surface of Mars and make sure that, we don't want to contaminate other areas. And then on the other side, we say, well, we really want to be careful because, if we contaminate the planet, then, how can we really say that we discovered, or if there was life, can we say that we discovered it? So it's a very important point to note in terms of how exactly we classify or determine how safe something needs to be for contamination. Now this is very interesting. I just opened this bag and I'm getting a bunch of blue pieces, but I need a black piece. That's because there's 8. Huh. Interesting. Let me see if there's another blue or number 2 bag I might have put down over here. Let's see if I missed any questions. Major concern. Yep, we got the sterile vehicles. SpaceX will use chemical reactions to make fuel to refuel on Mars. Will it take time to fill giant gas tanks, or is it easier to send tanker ships to Mars refueling orbit for some first human missions? That's a really good question. I actually made a video about this a pretty long time ago. I think back in 2018 or 2019. We talked in the video. We talk about this process of generating fuel on Mars, and how at the end of the day, if you have enough time and you have the resources available, which is another major part, then you can generate a lot of fuel. The only problem is you need a lot of energy, and um, you need a source of water. So this usually means you want to land closer to the poles. So again, if SpaceX maybe in the next 2 to 4 years sends a couple starships to Mars, they land, they have the technology to manufacture methane and liquid oxygen, be able to mine ice and use it, then that can be really effective. And over the course of another 2 to 4 years, when the next group of people come, then they can be developing those. They could be developing the fuel. The only problem is that requires a lot of assumptions. You have to have ice. You have to know where the ice is. You have to be able to mine it. You have to be able to collect it. And these, even though there's technological challenges, they're challenges that will need to be overcome in order to actually leverage the fuel. So at the end of the day, yes, we could send tankers alongside with the human or the crewed ships, but at the same time, just being prepared or being a few years ahead of time, we could also see future missions that are already fueled, or the fuel's already there in the case that we want to launch back off from Mars. I hope that answered your question. It definitely would. So just the amount of fuel that's necessary, it would be very difficult to send or it would be very difficult to generate that much fuel. We don't know where exactly everything would be. So I do imagine probably, the early stages will be sending tankers as well. But just like going anywhere in space, it always comes down to how much delta V you have, or how much control you have over your vehicles. And if you can't slow down, or you can't get back to Earth, then you're going to have to get that fuel from somewhere. So that's a very, very major point. So let's see what the next one is. So again, Milky Way. The thing is, after a human sets foot on Mars, contamination is no longer an issue. You can't sterilize a human. That's a very good point. And also, heat shield agrees. We have to consider contamination will occur no matter how careful we are at suits. Once we get there, it's tough to be certain. That's my only issue with rushing there. Let me make sure. That's a good point. Yes. So, once humans get there, then basically at that point, it's going to be up to where exactly we go, or how much we explore in terms of contamination, which is another major point. Yeah, that's a really, really good point. Let me see. I think that was that question. Oh, thank you, Bass Nation. I'm glad that you're enjoying the answers. I'm currently looking for what I imagine is a missing piece in a bag that I just opened, which is always fun. Let me see if this is... it might just need to be a blue one. So we have those. We have 4 of those. We have... Alright, so in this bag, we have 4 of these, and they gave us 7. Well, let me check. They gave us 8. 1, 2, 4, 5, 6, 7, 8. And we need 4 there. Well, that's interesting. 1, 2, 3, 4. So I think we could just use these other ones. Let's see. Oh, we do need another 4 there. Huh. It looks like we are actually missing some pieces. I think. Here, let me be right back. I think I will go get some pieces. Let me see if I can do this. I will be right back. All right, I am back. Let me go back to this view. All right. So there was a second bag too. It was just hiding in one of the boxes. But yeah, that's a very good point. Who said that? Let me go back to here. Racing MHF. That I should separate by pieces, and you are 100% correct. I was starting to do that, then I kind of got flustered that there was a missing piece. But it's in this bag that I did not see. I guess in other news, yeah, for contamination, it will be very difficult. Be very, very difficult challenge. And you know, even with Perseverance right now, who is doing an excellent job exploring Jezero Crater, and Curiosity, who is trying to understand more about the formation of Gale Crater, you know, it's very challenging for a robotic mission to actually prove, I guess, is the right word to say, that, you know, life actually once existed on Mars. That's something that will be very, very challenging for just one mission to come across and say, hey, this is something that Perseverance just, you know, woke up one day and found a fossil. That's usually science takes a lot longer than that. I mean, if you think about just discovering water on Mars, that's something that, you know, almost time and time again, NASA and the European Space Agency and many other entities that have explored Mars have essentially proven in different ways that, you know, there was once water on Mars. However, you know, some of the very first observations were still skeptical. It was still, okay, here is water on this dry planet. You know, how could it have formed in the way that we expect it to? And even more recently, looking at water on the moon, you know, analyzing that, you know, some of the craters in the polar regions could potentially have water, and even some areas that receive sunlight from, I think it was an analysis last year, which is a major component to the Artemis program. So it's interesting that over time, you know, it takes a while even to say that we discovered water somewhere, and to say that, you know, life once existed somewhere is also a very far stretch, or something that I don't think merely you know, a few observations from Perseverance could show. So that's why sample returns, or bringing samples back from Mars, will be very important, because the more data we can get, or collected samples we can get from Mars, the more observations we have in laboratories here on Earth. And with all that information, we can then say, hey, you know, here's some evidence that points towards, oh, you know, this could potentially have became from some organic matter or some organic process, or vice versa. Say, you know, this is not what we were expecting, or this is not pointing towards what we would want. So it's really interesting. All right, I've gotten a couple comments here. It could take decades or centuries to find what life might be there. I don't think we're patient enough to not send humans before that. That leaves the decades debate to should we go anyway. It's a very tough, like kind of like what I've been saying this whole time. It's a very tough question. You have, well, I guess depending on what type of sample returns are available. Because I don't know if it's officially been funded yet. I think there's been some analysis of the sample return mission through the Jet Propulsion Laboratory. But Perseverance is collecting samples, which maybe, I imagine will be, but maybe if NASA decides to pursue a sample return mission on Mars, then by the early 2030s, we should get samples back to Earth. Which could be very important to that. I think early 2030s to mid 2030s. But again, it's kind of that form of luck. Is one of the samples Perseverance selects, is that going to hold the keys to everything we want to know, or is it going to lead us to more questions? And naturally, in a lot of science, it leads to more questions, but they're not always bad questions. Abdo, thank you. I'm glad that you enjoy the videos. I'm happy to make them and learn more about anything that's going on in space and Mars and the future of space exploration. It's always exciting. But yes, again, thank you everyone for, I'm still going to keep going, but I just want to say thank you. This is the first time I've done a live stream, and so far it seems like everything is going smoothly, cross my fingers. No audio hiccups so far or anything too crazy. Besides the one hiccup of potentially missing a piece, but that was just me missing a bag, which is also very important. Me missing a lot of pieces. But just, I guess, as an update, so far we've only really built this stand right here. This is the only completed task. For the Hubble part, I guess I should show the big picture, the box. We're building the Space Shuttle Enterprise right here. And a part of it is the Hubble, which is this top part, which is what these first few bags are including. And on the back, this little tiny part right here, this one, is all that we've done so far. So there's still a lot that we need to do, basically the whole Space Shuttle. And Hubble, which I think right now is what we're actually building, is the Lego Hubble. So yeah. Let's see. Fascination. It would be so unreal and lone experience for the first astronauts to see red, vast Martian expanse and blue sunset as shown in the Martian movie. It would be pretty remarkable. I think, even looking back at some of the Apollo missions and the videos from Apollo 11 through 17, I think as much as they were very, planned and scheduled and thought out, and a lot of time went to just conducting science and collecting samples and planning instruments. You can see from the astronauts just how excited they were to be on the moon. And although that's something that was almost, I guess the most recent one, almost 50 years now, I hope that in the near future with Artemis and landing astronauts on the moon again, it'll be another surreal experience of, even though it's the moon and even though astronauts have been there before, it's a new generation of going to the moon, and hopefully it's a more sustainable process that can lead to more astronauts going to the moon, potentially with NASA's Gateway having a space station around the moon, as well as future, potentially, long-term future facilities on the moon, whether it be a moon base or so on, which I think the European Space Agency has some interest in. There's a lot of exciting stuff, even just going to the moon, and let alone sending a mission to Mars. That will definitely be surreal. So much of that we see through the eyes of our robotic friends: Perseverance, Curiosity, Spirit and Opportunity, Insight, Phoenix, so on and so forth. It'll be really quite the experience to see a human step foot on the surface of the moon, or a surface of Mars, I should say. I don't know. I'm excited for all of it. It'll be really fascinating. It'll be really interesting to see as everything is developing. Let's see. Yes, Martian Wolf, it is a tough one. Oh, the question? Yeah, it is a tough question. Figuring out how, where do we draw the line between I forgot I already forgot what I was going to say. Drawing the line between, when do we send people, or when do we decide, hey, we need to save this for astrobiology. Make sure we don't contaminate anything. Never separate pieces by color. That just makes it harder. Big type assembly already, but a bunch of big pile of pieces in the same color together, you'll never find them. Yeah, I'm just going to keep it by bag for now. I mean, if all these were open at once, much like a lot of older sets were, that were not separated by bag, then you would definitely be separating by almost every single type of piece, because that by itself would be very challenging. So luckily, I think it was like 10 or so years ago, NASA started doing numbered bags, or not NASA, Lego. Lego started doing numbered bags, and that makes it a lot easier the first time you want to build it, but if you want to build it a second time, then you'll be spending a lot more time sorting. And that, it could be fun, but it just extends the total duration of the build. Let's see. Hi, all decided to tune in. Hi, Adam. Thanks for tuning in. Make sure you mount the mirror as well. Yeah, I don't want to... I mean, luckily enough, if I need to make a change to the mirror, then it won't require another shuttle launch. It just requires me to make some fine-tunements. Oh, I put this piece on wrong. Let me use this brick separator. Oh. Let's see. Between Venus and Mars, which one do you think will be colonized first? Colonized first. That's a very good question. So Mars, as of right now, definitely has a very popular interest in sending people there. Having a colony on a planet, or having, sustainable human presence, is going to be really tough. It's going to be really, really difficult. Even more so than just sending people. Personally, I would like to see a permanent base on the moon before anything crazy happens on Mars, or Venus for that case. But just because of, a lot of interest in Mars, I think naturally it will be Mars, which will be the first that we have a permanent colony. And now I should say that although there are up-and-coming Venus missions that are going to be launched in the end of the 2020s and going into the early 2030s, Da Vinci Plus and Veritas, and the European Space Agency's, I can't remember the name of it. It was announced right after it. I believe I forgot the name of it. Let me check really quick. European Space Agency, Venus. The Envision mission, yes. As there'll be a grow in demand or interest in Venus as we send more missions to Venus over the coming decade. I personally think I might have also put these on sideways. Let me check. I personally think that Mars will probably have the first sustainable presence, just because of a lot more of an interest right now. And yeah, Milky Way says Mars 100%. But who knows? We might discover something incredible about Venus, and it is a little bit easier to get to Venus, and in terms of solar power, if you want to have a cloud city, it could give you a lot more benefits. But both of them are very difficult. Hello, Super Forjet. Hi, just jumped in here. I'm really excited for the moon missions. What do you think happens sooner, the crewed moon landing or a Mars landing, crewed or cargo? I definitely think a crewed moon landing will happen first, by a lot. And the reason for that is because I guess that question, Super4Jet, again, thanks for listening in. The big point of that question is the fact that you're probably referring to SpaceX and Starship. And since Starship has recently been selected currently as the sole provider for, I think this is where I flip this around, has been recently selected as the sole provider for the HLS, or NASA's Artemis, then I think they will put a large focus on landing things on the moon. With that being said, maybe they'll send a Starship to Mars, but testing moon landing, making sure that it's safe for astronauts, that will be something that will be a high priority in the near future for SpaceX and NASA. So I do think that a crewed moon landing will probably happen first before a crewed Mars landing. But with that being said, a cargo Mars landing, I guess the main question is, what all are you sending to Mars? And I don't know how much of that has been worked on yet. So who knows? The tough question. If I had to say, I would say probably a crewed moon landing in the next 4 or 5 years. Because if we're sending a Starship to Mars, we want to make sure we have an effective cargo that we actually want to send there. Let's see. Bass Nation has the question, but Venus has a dense and toxic atmosphere and high temperatures. Yes, that's a great point, Bass Nation. I actually have a video about this. I think it was in 2019, maybe early 2020, that talked about going to Venus instead of Mars. And one of the main points about going to Venus instead of Mars is the fact that you aren't going to the surface. Instead, you are going to a pretty large altitude, high up in Venus's atmosphere, where even though it's still primarily carbon dioxide, you have essentially a large amount of, or you have a lower pressure outside, meaning that you wouldn't need a pressurized suit. Instead, you just need an oxygen suit. And the temperatures are much more comparable to that on Earth. However, one of the main challenges with that, as we could probably imagine, is if we have a sky city, we aren't going to be able to access the surface easily. So developing a colony on Venus, which is truly just a sky city, will be very challenging. And putting one on the surface of Venus will also be incredibly challenging. So that's kind of my 2 cents there, is that if we're going to have a colony on Venus, at least in the near future, it's going to have to be in the sky. Yeah, and Milky Way kind of just pointed that out exactly from what I said, is that you can't land on Venus without being destroyed very quickly. And hopefully, it's been a long time since NASA has gone to Venus. And hopefully with the Da Vinci Plus probe, which will be, again, launched in the next, or by the end of the 2020s, hopefully we'll see how well NASA can develop a probe that sustains time on the surface of Venus. Since it's something that we haven't sent in a very long time, I think it's 30 years, actually, last time we went to Venus. Or last time NASA went to Venus, I should say. That, we're basically we can basically test our technology and say, okay, well, we know that we're probably going to not function for very long on the surface, but maybe we can try and function for, a few hours or maybe even a day and see if the technology is actually able to handle it or if we still have a lot of problems to face. But again, that's for robotic missions. I don't think there is a plan for a crewed Venus landing on the surface anytime soon. But yeah, so far we're building the side of Hubble. I don't know if it's starting to take shape a little bit. Let's see. Mind if I ask about the F-117 project? Hands-on one, almost my favorite aircraft. What's the scale? Oh, scale of a model. Let me take a look. Not familiar. Oh, wow. So yeah, we're currently assembling the NASA's and the European Space Agency's Hubble Space Telescope. This is not in space manufacturing since we are building it on Earth. But maybe one day we can build something and build a Lego set in space. Again, I want to say thanks for everyone for tuning in. I'm not ending anytime soon yet, but I really appreciate everyone that's been able to tune in or listen in to what's been going on. This again is my first time ever trying to live stream, so it's a big learning process. It's also much more difficult to build Legos and multitask. I feel like it slows you down a little bit. Another question from Super4Jet. Also about the cargo that goes to Mars, what do you think might be necessary to get to the surface before or while crew is arriving? Like life support, science instruments, construction materials? That's a really good point. So again, this is something that is, something that isn't really, talked about in terms of a development phase right now, at least not that we know of publicly by either NASA or SpaceX. But, preparing for a human Mars landing, will require a lot of resources. We talked about fuel a little bit earlier. You know, having the fuel to get back is critical. Assuming that we're doing a round trip mission, which I think is a pretty big assumption if NASA is involved. But with that being said, you know, oxygen is something that can be scrubbed, so carbon dioxide can be scrubbed, and that's something that we see on the space station. You can also get oxygen from ice, which again will be somewhat of a challenge depending on where we land on Mars, but you can also get oxygen from carbon dioxide, or, you know, the the process that MOXIE is currently doing in terms of getting or separating carbon dioxide into carbon and oxygen. So for life support, you know, oxygen is something that, even though we might want to bring, it's definitely something that we can access from Mars. And, you know, MOXIE on the Perseverance rover is showing that, or has showed that. I don't know how much they've done more recently, but during some of the early months, they were able to test that it was able to produce oxygen at the levels that they were expecting. Although it will take a lot of power and a lot to ramp up that system, and I talk about that more in one of the videos I go into it on. You know, we can produce oxygen. For food is definitely going to be a big one. You know, producing food right now in the International Space Station, there have been some success in growing different types of vegetables and so forth, and there's a lot of research into testing various growth rates, or vehicles that can or not vehicles, sorry, plants that can grow in Martian soil, or, you know, be affected by perchlorates that are in the soil. So there's a lot of tests and analysis in terms of what needs to be brought. But for life support systems, you know, food will probably be a big one. You know, having oxygen and water will be major. I don't know about construction materials, at least for the early stages. I imagine that an early stage starship that lands on Mars will require, will have to be able to land on Mars and launch from Mars without having a launch pad, which, you know, maybe long term isn't going to be necessary, but at least for the early stages it will be. So that's something that we might just have to wait and see. Let me see. This is... So here's a piece I wanted to show. This is not a sticker. This is actually a piece, which I really appreciate. You know, it kind of looks like a sticker, but it's not. Go. Really appreciate when NASA puts, or not NASA, Lego puts them right directly on them. Just something to consider. But let me go back to the question. Or some construction materials that might be necessary is to prevent radiation. So maybe whether it be, you know, operating regolith to put around a structure, you know, having a structure, maybe purposely using a cargo starship or vehicle, something to live in, to stay away from radiation, which will be a major part. But I imagine one of the biggest components will be scientific instruments and keeping, you know, having the life support to keep astronauts alive. Well, Starship development is kind of a mix between LEGO and Kerbal Space Program. That's a really good point, Milky Way. Honestly, I think SpaceX might be capable of building engines faster than I can in terms of doing it in LEGO, which is very impressive. But they definitely have shown to be pretty effective down in Boca Chica. Let me see, I think I need to switch one of these. Again, the challenges of building and talking at the same time. Oh, more talk of the model. Sounds very interesting. Thanks for the awesome videos. Thank you, Bass Nation. Oh my goodness, thank you for the I guess super chat. I don't know, I've never done this before. Wow. Thank you so much. Thank you for being one of my favorite channels and to motivate you a little bit more to do more live streams. Well, thank you. I really appreciate that. I'll have to especially build this, but in the future do more discussions and watching launches of seeing what exactly is going on. But wow, I really appreciate that. Thank you. As I currently have to fix the thing that I built upside down. Let me just make sure that this is the right way. But back to the question about sending cargo. I really don't know what, you know. There's a lot of focus on what would need to be sent before astronauts get there, and it's going to be hard to construct anything before anyone's there unless they're going to send robotics or robots to construct things like a base or a pad or something. Which, who knows? It could potentially happen. But I think, a lot of that construction might have to be done by people. So I think definitely the early stages are going to be more scientific. Honestly, a lot of these early Starship missions could very well be try and do sample returns. That could be a proof of concept for NASA being able to bring astronauts back. It could be a proof of concept of bringing large quantities of the Martian soil back. It could be very important for NASA to be able to test those things, or SpaceX to be able to test those things. It can really show a lot of components of the procedure, which I personally think would be really exciting to see. Bringing back large boulders. The only challenge is, if we do that before we send astronauts, how do we get the boulders on Starship? Are we going to build large robots to pick them up like a crane? Are we going to have, sample caches like the Perseverance rover? That's a big point. Thank you again, Milky Way. I really appreciate that. Heat Shield says, I like the idea of finding a nice flat level landing area for the first Starship to land on in its own legs. Then it will be disassembled and used for parts of a landing pad. Need to send a cutting and welding bot. That's a really good point. If starships can be developed at the cost that they are, and or are planned to be, I should say, then I wouldn't be surprised if, coming like a few years down the line, we're sending a lot of starships just to be, the center of a base or the center of some location that we want to be at. Just because we need a lot of infrastructure there. We need a lot of resources, whether it be steel or other available things for constructing bases or housing or scientific instruments or whatnot. I don't know about a landing pad. Landing pad might be challenging, but I guess you could roll out, or like you said, weld the structure to be able to be drawn apart. I think also looking at even the most recent, I guess I should say, is the Perseverance landing. Some of the images that it got back back in February when it landed on the surface of Mars, those videos, even though they're amazing to look at, and I could watch them all day, even though they're amazing to look at, a lot of that's going to be really useful for understanding how do we land larger vehicles. The Perseverance rover, much like when they first launched Curiosity, they're trying to reach the upper bound of how much they can carry on this vehicle. How much can they re-enter the atmosphere with the sky crane strategy? And over time, over the last, I guess from 2012 when they landed Curiosity to 2021 when they landed Perseverance just this year, they've been able to optimize it, improve, and really, draw as much as they can to land a larger mass. And Perseverance is heavier than Curiosity, it has more instruments, and they were able to remove some of the structure in order to have these instruments and capabilities. But at the same time, when they're videoing this landing, it really raises the question of, okay, well, we can land Perseverance and we have all this dust being kicked up, but what happens when we want to land something that's a lot bigger? And, they're, I guess, a lot bigger in this case is referring to Starship. How do we prepare for that? How do we know when we want to land a Starship? How hard of a surface do we need to look for? And even knowing all that information, the terrain relative navigation, Perseverance didn't know where it was going to land before it landed. That was one of the main improvements of the design, is that they could really hone down on regions that they could land in. So it would be really interesting to see how the videos and the data that they collected from the Perseverance landing will help understand how we can land larger vehicles on Mars, even without a base. I kind of went on a long tangent there without looking at questions, but I think that's a pretty important concept. You think that there will be a water room in Starship to lock people during radiation bursts in transit? That's a really good point. Water does a really good job a good job at protecting people from radiation. I guess one of the challenges is how heavy that will be, but only time will tell what Starship will have to give for some of the mass properties and ability to maintain water. But yeah, that is a really good point. While we're getting to Mars, keeping the astronauts safe from some of the solar wind and some of the energetic particles is going to be a challenge, and having that type of room will be very important. To maintaining the safety of the astronauts. But again, it's, you keep saying, oh, we want to include this and this and this and this, and before long we have this long, extensive list of everything that, even a single Starship might not be able to carry. So just like the iterative design, you make improvements one place and you either have to find a lighter solution or you got to replace something else. So it's a challenge. It's very difficult. Very difficult. Heat Shield said, simple pad, nothing extravagant, just a flat surface to hook engineering sensors and fire suppression onto. Yeah, for Mars. I guess if we're on Mars, we don't really need to worry about fire suppression too much, since the atmosphere is completely carbon dioxide, or mostly, it's not completely, vastly carbon dioxide. So, runaway fire, the only fire that's going to be coming from anything on Mars is going to be from the engines. There's no oxygen, or very, very little oxygen to burn. But that's a good point, having a very simple structure that we can just land on, a flat bed that just is enough for Starship to not have to kick up any dust or regolith or dig itself into a hole. And I think they'll learn a lot from the moon landings. When HLS or when Lunar Starship goes to the moon, understanding how they can land on the lunar regolith and leveraging some of the information from the Apollo era will be very important to, successfully landing, not digging themselves into a crater, having all that insight. So it should be interesting. It should be very interesting. But yeah, very exciting. So far we're still working on Hubble. Kind of starting to look like it. Still no telescope in there. Some Legos. A lot of people agreeing. Yep, I agree. Let's see what ever-changing SpaceX ends up with. The ever-changing SpaceX. That's a very good point. And it should be exciting, even with SpaceX and hopefully, for example, Rocket Lab, which plans to send some missions to the moon and to Mars or to Venus. I don't know if they have a mission to Mars. They might. I don't think so. I think they have a mission to Venus planned. They might have a mission to Mars. I'm not sure. And with relativity space and hopefully Blue Origin and Boeing, hopefully a lot of these companies can get involved and show interest in making an impact and getting us to the moon and Mars or Venus or anywhere in the solar system for that matter. With upcoming missions like Dragonfly and so on and so forth, it's going to be really exciting no matter who's launching some of these. I keep looking at my computer, but I should be looking at the camera because that's who I'm talking to. Again, thank you everyone. This again is my first time live streaming, so it's a learning process. It's getting lost in Lego. I guess I should probably move this up a little bit so you can see more. That is a good point. Fire suppression will be very important if there is a hard landing. That is an excellent point. I don't know. That's the thing, is I don't know. That's a really good question or point, heat shield, is because you have this propellant mixing, you have a burst into flames, you have the oxygen and methane. I don't know how long that burns. I don't know how that would react because we're so used to something burning on Earth. We're used to, whether it be one of the early Starship tests or, launch abort or something. We're used to something igniting and then this perpetual flame. It would be really interesting to know how something burns, even propellant mixture, how that would burn on Mars. If you had something, not say land on a landing pad or just a crash landing, how would that burn? Would it be almost an instantaneous explosion and then die out, or would the gradual mixture continue to burn? That's a really, really interesting point. I've never really thought about that in terms of how it plays a role in Starship or in landing, I guess. It's the gradual burn. But yeah, we definitely don't want a hard landing on any landing pad. That'll be a challenge. Dragonfly will be a major one. Yes, Milky Way. The photos of methane lakes and rock-hard water ice. It'll be completely foreign or alien. It'll be an alien world, really, to see what it is like. I am very excited for it. It's such a foreign idea, a moon that has the right conditions, the right gravity, the right atmosphere to make it easy enough to fly, with this large vehicle that conduct a vast amount of science, and now with ingenuity and the success of flying something on Mars, understanding how we can maintain flight and go from place to place and prepare for future flights and so on and so forth. It will be truly exciting to see Dragonfly fly. I think it'll be a really one-of-a-kind mission until we can send another quadcopter Bass Nation asks, will CO2 on Mars kill fire? Well, that's a good question. I would imagine so. I would imagine, maybe the entire atmosphere would kill fire. Again, I guess it's hard to know what um, it's hard to know what a fire would even be like on Mars. And I know it's kind of weird to say that, but it's just because kind of like what I said earlier, we're used to this idea of, okay, well, we light a fire, it grows because of the oxygen in our atmosphere. Or, it sustains because whatever fuel we have and the heat can be burned because of combustion, because of oxygen. However, since we don't have that oxygen on Mars, the only thing that will burn is the oxygen fuel. So if that is being burned in a carbon dioxide environment, then I don't know. I don't know if it would. I don't know if extra CO2 would put it out. I don't know if just the atmosphere would put it out. That is a very interesting point. That's something I'll have to do some looking into. Fire on Mars. Yeah. Thank you, Heat Shield. I'm glad that you're enjoying it. It's fun to be able to talk about all the different space things that are going on. It's exciting. Probably not as exciting as a launch, but it's still a lot of fun. Yep. Moo Scoop. Yeah. Lack of oxygen and pressure will definitely do it. Naturally, right? If you have fuel, who knows? If you have, just open oxygen and methane fuel combining, then that could definitely be a problem. But if it's just open to the atmosphere, then I doubt that a fire could sustain for very long, or if at all. How much is the cost of this Lego kit? I believe this one is around $200. So a good rule of thumb for Lego sets, so this one is 230 or 2,354 pieces. Usually the average Lego piece is a little bit under 10 cents or a dime in the US. So if you see a Lego set, you can kind of approximate how much it costs by the number of pieces. That's just a little fun fact. But since this is a lot of smaller pieces, it's generally going to be a little bit less than that. So this one is $200. How about a live stream during launches? Potentially. I guess it depends on the launch. But it would be interesting to see what launches are going on and be able to talk about some of the concepts. I know there's a lot of very, very excellent channels out there that do great jobs covering live streams or live streams during launches. So I also really enjoy watching some of those just to learn more about what's going on. But potentially, could definitely be interesting in the future. Imagining that this will probably take definitely more than today. So maybe the next day or so I'll be doing kind of continuations of this and keep asking questions. I have quite a few extra pieces. I must have missed a step somewhere. I feel like it told me to build 2 of something when I only built 1. Oh, it told me to build 4 of something when I only built 1. That's what it is. That'll do it. I like your comment. Keep doing it. Content, not comment. Content. Thank you, Red5. And if you haven't seen, this is also another self-plug. Earlier this morning, I posted another video talking about the accomplishments of NASA. If you haven't seen it, I do recommend it. I guess I recommend all of my videos because I make them. It's a really interesting video. It goes into some of the early, it's actually the first in what I plan to make 2 more videos, going into every single year that NASA has been around. We look at their major accomplishment for that year. So, for example, we start in 1958 when NASA was first founded by the U.S. Congress. And then we go year by year looking at some of the major successes, starting with Pioneer 1, which was their first spacecraft, going through some of their first orbital launches, their first crewed flights, going all the way up until 1977, I believe, which is when they started to do some of their first flight tests of Space Shuttle. So we go all the way through the Apollo era. We recognize their greatest accomplishments from each year, and we learn a lot about, just NASA in general, how they progressed during this, 2-decade time frame. It's incredibly impressive what all they were able to achieve. So it's just, I personally really enjoyed making this video, and I highly recommend, if you haven't seen it, going to watch it. Yeah, another self-plug there. Imagine I might see a few viewers drop because of the recommendation. But that's okay. We're just having a fun time here building this space shuttle. And I'm figuring out where I missed another part. Here it is. Yep, here it is. Heat Shield says, math. So you're telling me that a 7-foot tall King Tut Lego statue I made with mostly flats could have been sold for $200 million. Oh man, I wish I wasn't that dumb when I was young. $200 million, let's see, doing that quick math in my head, that means around, 10 cents a piece. That's let me just tell you, that's a lot of Legos. So I don't know that, I might have to take you up on that offer, Heat Shield. That would be a good one. Let's see, Space 4Jet, SpaceX Mars, as they are not going to send 1,000 people at once. What do you think are the most needed professions? I imagine scientists, engineers, and farmers, but what would logistics and workers? So that's a very good point. Viewer count doubled in the last 30 minutes. I don't know if that's viewer count here or on my other video, but either case, that's fun. I'm trying to figure out. So professionals to go to Mars. Yes. So first, let me open this third bag because the last time I opened a bag, I forgot a piece or an entire bag, which would not be good. Also, I guess an update for what it's looking like. We have the telescope or the mirror, which I hope is functioning well, or else we might need to get another shuttle to come up here and fix it. We have the NASA logo and the European Space Agency logo right here. This is the worm logo. I would imagine this is realistic to what's on Hubble, but I didn't know that the worm logo was on Hubble. But yeah, I think we're going to be working on this back half here. So back to the question. Actually, first, let me get bag 3. It should be this, and it should also be these, which are not stickers. Interestingly enough, never seen this before, but they're just kind of foil paper-esque. Okay, so in terms of the first professionals that will probably be going to Mars, we can probably look historically at NASA astronauts' early time frame. And the reason I say NASA astronauts is because most astronauts during the Apollo era were pilots. They were test pilots. They had to, generally a lot of the computers or flying the actual vehicles would require some form of human in the loop, some kind of pilot to overcome if something was to go wrong. And from what we've seen, especially in the recent years with the Falcon 9, is that a lot of this is starting to become more based off of not artificial intelligence, but machine learning, and using computers to make really quick decisions that can help improve the vehicle performance. And this is probably most commonly known for Falcon 9 landing their boosters. Not necessarily Dragon. Dragon also leverages a lot of programming or computer flight. But especially landing Falcon 9 has really shown that we can use computers really well to land vehicles that are inherently unstable, that are very challenging to do so. That I don't know if a pilot, probably a pilot could, but I don't know if a pilot could land a Falcon 9, just with a controller or whatever. So, historically, a lot of Apollo astronauts were pilots. In Apollo 17, one of the astronauts was actually selected for a geologist, and that was one of the missions that actually collected the most rock samples, because a geologist going to the moon collecting samples would know the most about what they would want to collect. And even though astronauts do get training in all the fields or many disciplines in what they'll be using, if you have an expert on the mission, then that can be critical to just that slight improvement. Just having that historic knowledge of something can be really important. So when we say astronauts, nowadays astronaut is really becoming this term of someone that is a part of the space program that's going to space, but really can have a wider range of backgrounds, whether it be engineering, whether it be geology, whether it be medicine, whether it be biology. There's a lot that goes into that. And I definitely think the early explorers will probably be that same group. There'll be a lot of scientists. It'll probably be geologists going to Mars. It'll probably be some biologists, maybe even, or astrobiologists that are looking for different types of structures or microbial deposits or whatnot. And then even further from that, you'd need people that will be able to operate with the vehicles, and doctors, and it will continue to grow from there. So I imagine that a lot of the early explorers of Mars will probably have that type of STEM background, the type that focuses a lot on, having a wider range of experiences that can be helpful for different types of missions on the surface. So let's see. From Fast Nation, why do you think space exploration, or why do people think space exploration is waste? Like NASA doesn't care about Earth? That's a very important question. And this is one of the major questions for, why do we explore space? And when we think about space exploration, generally you hear, I guess, a common trait is you hear how much it costs for development, how much it costs for a mission, whether it be a Mars mission, whether it be the Apollo missions, whether it be landing humans somewhere. A lot of what it looks like is it comes to a number, and it's how much money are we putting into this, or how much money is going into this program. And I think a lot of people understand money more than, or a lot of people will relate with money more than a lot of other things. And there's all sorts of spin-offs that come from space exploration. There's GPS, there's medical improvements from the space station, there's all sorts of just completely almost what you would imagine would be unrelated to space exploration that has a major impact on society here on Earth. And that connection or that development isn't something that's easily tieable to it. I think a major point to all of it, though, is that NASA is very much a scientific or a research-based program. And I guess we could tie this in with other space companies as well later. But from the very nature of it, NASA is trying to understand more about the universe, planetary formation, planetary sciences, Earth sciences, understanding more about how the Earth acts, all this types of stuff. Understanding so much about how Earth works that, from a very fundamental standpoint, NASA really is a research center. And research, you never know where research is going to lead you. Research can give you incredible results. It can give you so much information, or you can run into challenges that you never expect. You can have your eureka moments where, you did something and it completely didn't work, or you did something and it worked exactly how you expect it to. And that combination is what's amazing about research, is because you learn from a lot of what doesn't work. And the challenge with that is it does have a price tag, but at the end of the day, something that NASA discovers now can make a critical improvement to how we operate here on Earth 10, 20, 30 years down the line. And the reason why we don't necessarily tie those things together is because a lot of that technology, whether it be patents, whether it be technology development programs that go out to companies, a lot of those become companies, and then a lot of those companies, grow off of it and become successful and leverage that technology. But most of the time, no one really ties it back to NASA as one of the key sources of development. For example, looking back at Apollo, there's a lot of technology, a lot of developments, even in computing, that although computing was being improved by the side, understanding or improving computing for the Apollo missions, making it smaller, making it more operable, really could help in not only funding those early stages of computing, for what now we're using computing to live stream a Lego build. So everything in science is connected, and there's direct impacts, like Heat Shield said, helping farmers, understanding the climate, food production, medical breakthroughs, all that, which is very direct. And there's also indirect impacts, which is improving technology, which can eventually help aid in humanity and growing. And then that's kind of why I wanted to tie it back to companies, is because NASA in the early stages really did put a lot of research in how you fly rockets, how you fly vehicles, how you actually operate spacecraft. And now we're starting to see a transition where a lot of that is going into private companies, SpaceX, United Launch Alliance, Blue Origin, Rocket Lab. I can't believe that name just went away for a second. So many of these companies that are leveraging what they know from, or what they've learned from NASA, can be very important to knowing, or to creating that infrastructure that goes to space. So let's see. So it does require knowing what's going on, and CAT scans example of something that was developed by NASA. There's a lot of really good reasons, and I think another major part of it is our general unknown. Science is something that has always been, or scientific exploration is something that has always been a curiosity, something that we want to learn more about, something that we never know what's going to be over that next hill, or that next, across the next ocean. And in this case, we understand a lot about some of these main concepts. We know how long it takes Mars to orbit the sun. We know how long a day on Mars is. We know, generally how hot Venus can get. But at the end of the day, there's still a lot that we don't know about these places. Just this past year, there have been some studies that say, hey, there might be organisms alive in Venus's atmosphere right now. And then, a few months later, some people say, okay, well, maybe some of the science points towards it, some of it points away from it, but we really don't know. And to realize that our closest neighbors, the moon, Mars, Venus, the closest celestial neighbors we have, and there are still major questions that we don't know the answers to. That just learning a little bit more about what's happening on Mars, or what happened to Venus, or if life existed on Mars, or if life existed on Venus, can teach us so much about science as we know it today. And I think that's a very important part to addressing NASA. But yeah, that was a very good question. Thank you for asking that. But as we were asking that, we put the shield on Hubble, so it's also fun. So yeah, that was a very long way of saying we kind of know. But yeah. So really quick, I guess, for anyone that's new or tuned in, we are building the Discovery NASA set. Here is the Lego Space Shuttle. Here's the back of it. We have not done any of the Space Shuttle yet. Well, no, we have not. We have made this right here, which was very quick. That was the first couple minutes of the stream. We're currently working on Hubble, which there's a very bad glare. I apologize. But we're currently working on Hubble, which is still currently in orbit. It is still currently operating, knock on wood, I hope. And there's still a lot to learn from Hubble. Question from Bass Nation or Point. Did you see the 3D printed rocket video by Veritasium? I don't know if I did. I don't think I have. I know Relativity Space is working on 3D printed rockets. I think I've lost the name again. Rocket Lab. I think they also do parts of their program as 3D printed as well. But I mean, when it comes down to it, I didn't see that video. I'll have to check that out. Here we go. I guess as a side point, I haven't made a video about this, and I always plan to make videos about perseverance and ingenuity, but unfortunately I never have the time, and I say that as I just released a new video, not about them. But the Ingenuity, I think today, might have already happened, was supposed to conduct its 12th flight, which is very exciting. It was supposed to use its color imaging to go back and forth over, I think, a 5-foot area or maybe a 5-meter area to see essentially what is a, how can I put this? Or to create a 3D render of the area that it flies over. And the reason why that's important is because where it's flying over is somewhere where Perseverance, they do not think Perseverance can go, because the soil or the regolith is too sandy, it's too dusty, and Perseverance could potentially get stuck. So Ingenuity is going over these regions, these ridges, to see if it can kind of identify some regions that might be of interest. So it's very interesting to see how Ingenuity is being a major help to the Mars 2020 mission. I personally absolutely love every single picture that comes back from Ingenuity. Oh, the video is of Relativity Space, the 3D printed video. Okay, excellent. I have heard and followed a little bit about what they're doing, and I know that they're working on, I can't remember the name of their vehicle. Well, they're working on a couple vehicles. But yes, they plan, I think they're in Long Beach, California, but they plan on working on some very interesting developments there. And that's, again, another major exciting thing about space right now, is that there's just so many different companies that, there's a lot of startups and a lot of small launch providers that are growing, and ultimately, realistically, probably all of them will not succeed. Who knows which ones will? Maybe all of them will, and that would be awesome as well. I would love to see every single one of them succeed. But it'll be really interesting to see how a lot of these concepts grow, how, a lot of risks will be taken, and some of these small sat providers will be able to push the bounds in one way, shape, or another. Whether it be air launch through Virgin Orbit, whether it be reusability through well, I guess, reusability through Rocket Lab or what Relativity Space is doing. It'll be really exciting. So right now, I think we're building, not sure what this is supposed to be. Potentially the some of the radiators or some of the foil that goes on the edge of the Hubble to keep the temperatures lower. I'm not 100% sure. It has this yellowish color, which is why I think it might be the gold foil, but it could also just be some sensor or electronics or some sort. It's 2 a.m. in India. Well, thank you very much for staying up this late. I really appreciate that, Bass Nation. Hope you enjoyed the live stream. King of worried about sample collection. If they keep crumbling in the sample tubes, we may never have a sample return as planned. Yes, Milky Way, that is an excellent point. So I guess as an update for anyone that might not be aware, the Perseverance rover is on Mars, and it has been on Mars for 6 months now. It is currently, well, it spent a lot of time getting set up, updating its software, watching Perseverance fly, which has been on, or sorry, Ingenuity fly. Perseverance is not flying. That would not be good if Perseverance was flying. But Ingenuity, the Mars helicopter, it's been watching it fly. And now that it's getting into the summer, or the summer for the Northern Hemisphere, NASA has been starting to work towards sample collection. And this is a pretty big part of the mission. This is because they want to sample, not quite sure how I did this backwards. They want to sample parts of the Martian regolith to bring back to Earth. So they have these little sample canisters, and essentially Perseverance will dig a hole, pull out the small core of the hole that it digs, and it will put it in a sample canister, which it'll either carry or drop behind itself to later be picked up by a different rover, which will launch it in a rocket that will come back to Earth. So long story short, Perseverance is collecting samples which one day, hopefully, will come back to Earth. So just last week or the week before, NASA had been working for a while, getting everything set up, testing everything, seeing if it works. And they performed their first core test. So essentially they get into a drill, they would take pictures of everything, make sure everything worked. And the drilling went well. It was able to drill into the surface. It would grab the core, it would put the core in the canister, and then it would take a picture of the canister and of the hole and see that everything worked. And it took a picture of the canister and it was completely empty. It had no core in it whatsoever, which was a major surprise to a lot of people because there was supposed to be a core in there and it was just completely empty. So then they took a picture of the hole, and from first glance, the hole that it dug also appeared empty. So for a couple days there, before NASA really stated anything else, they said, or a lot of people were kind of on this scavenger hunt for the missing core sample. You know, where might it have gone? What might have happened to it? And recently, as of, I think just the last couple days, NASA put out or the Jet Propulsion Laboratory put out a claim saying that the rock that they actually cored was not the material that they were expecting. In fact, out of all the tests they did here on Earth, something like this had never happened, which shouldn't, I mean, we say that because all the tests happen on Earth, and this is Mars, so it is different. But it is surprising that, this still happened. However, they believe what was actually the main cause, or why it didn't core as well as they wanted it to, is because the bedrock that they thought they were sampling was actually a lot more brittle than they were expecting. So when they drilled into it, instead of creating a nice core sample to take out of, instead they got what would have essentially become a pile of dirt, and the pile of dirt would not go into the sample container. So instead of trying again there, they decided to go to the next location where they will attempt another core. So it is quite a challenge. There is still more that they have to figure out, for sure. Let me see. Let me put this over here. Yeah, so there's more that they need to figure out in terms of sample collection, and I hope that the second one goes well, because if it does not, then that could be troublesome. But I hope that that first one was maybe a fluke, or that, you know, they can maybe pick something that they expect to be a little bit more sturdy, or maybe even core from a different angle, because I'm pretty sure that the sampling has the capability to instead of core directly down, it can core 45 degrees or 90 degrees or a range of angles. So it might be better to collect samples in that case. But yes, the ability to collect samples is going to be very important to a sample return mission if we do want to send, if one is sent, I should say, in the late 2020s, early 2030s. But yeah, that's a very good point, Milky Way. Well, that's something we'll just have to follow along and see what happens with it, because again, Mars's rocks and regolith surprises us again, from going all the way back to Viking 1 with some weird behavior with the surface, the sticky soil, to the InSight lander not being able to dig further than, you know, a few centimeters for their heat flow probe, all the way now to Perseverance having difficulty actually selecting a core. But again, since we don't know a lot about it, it's a lot to learn. It's a surprise, it's a eureka moment that maybe can teach us a lot more than how Mars works and how everything kind of works on Mars. So just have to wait and see. So what we were just building is this side of Hubble, right here. Now we're putting together these. I imagine the next one will go right here. Then we'll probably cover this up. Yes, the sand is hard and the rocks are soft. Yes, that's a great way to put it, Milky Way. Milky Away, sorry. The where we thought it would be desert and simple to just send a probe right into the soil, you know, they ran into challenges, and where we thought it would be bedrock in the bottom of a crater essentially, and maybe be igneous and pretty easy to sample, it turns out to just crumble away. So everything, you know, the sunsets on Mars are blue and the skies are grayish, sometimes red and dust clouds, so it's almost like the exact opposite of what we expect. That almost makes it more exciting, because we can learn more about how it works and what makes it so different. Because really, we went to the moon and we collected a bunch of moon rocks and we explored the moon, and the moon gave us a lot of information, and then we brought the moon rocks back and we realized that, hey, the moon is actually Earth, a lot like Earth, and that, you know, the Earth and the moon could have once been the same thing. But now we're working with a planet, anywhere we go, we're working with planets or moons or comets or asteroids that just are completely different from what we expect. And every time we go, we have that strange moment. And that strange moments lead to, huh, you never would have thought that was the way that things worked. Which I think is personally really interesting. Because if we went there and we said, oh, it's a rock just like how we understand all the other rocks, then I don't think it would be as exciting as if it was, huh, that rock didn't act the way we wanted it to. Wonder why. Then I guess for sample return, we want it to act the way we want it to do because we want to bring it back. I think it's also good from a, from a scientific standpoint. We want it to be like, huh, that's strange. But from an engineering standpoint, or Ingenuity, for example, you don't want to start flying Ingenuity and realize that our complete understanding of flight is backwards. But I guess it's good that Ingenuity's been working so well because at least we understand how to do that. Thank you, Simple4Jet. I really appreciate it for you stopping by. Yeah. I think at the very beginning I was saying how long this would take, but this definitely is not going to be finished today. So I'll probably be doing another one of these probably tomorrow and maybe in the coming days. Try and get as much of this done. Alright, so now we're putting the back half of Hubble on. Here we go. We're putting that half on. We have most of this covered up. We still have this area right here, but it's really starting to look like Hubble. And we need the solar panels, obviously. Oh, as I say that, we put them on. Not the solar panels, but the siding. Yeah, I guess since we're working on Hubble, interesting question, which I'm interested what you all will have to say is, Hubble is definitely coming to the end of its lifetime, as sad as it is, with some of the recent backup computers and challenges that it's been facing. I wonder, because Hubble has been pretty revolutionary for space exploration, or for astrophysics, I should say. Do you think that Hubble will be saved? Do you think that there'll be a mission to go up and collect Hubble in maybe a starship or some other vehicle and bring it back down to be put into a museum? Do you think it might have its orbit raised to stay in orbit for maybe tens of years or hundreds of years, maybe thousands of years? Or do you think that it might just stay where it is and eventually decay and then that'll be it? I mean, I personally would love to see it be saved. I think a lot of people would love to see it be saved. But that's just something that I think it'd be really good if it was saved. Because then we could have it in a museum and we could recognize an amazing feat of technology. Because other than impactors, a lot of these landers are still on surfaces and still doing things that having a major importance in how or if we can go there and eventually get them. But oh, hello, Sarah, Lynn, you're so fun. Love watching your channel. Well, thank you very much. Thank you for joining the live stream. Milky Way, way past dinner time here in Portugal. Well, thank you for staying up, and thank you for waiting to have dinner. Good night there. And does Jupiter have water? That's a very good question. Let me get to that in just a second. But yeah, so I was saying with Hubble, do you think Hubble should be saved, or do you think it should just be able to be deorbited or not? I mean, I think a lot of people want it to be saved, but having to pay for a mission that goes up and safely brings it back down would be quite a bit. So I guess it all comes down to the money. And also, for anyone that's new here, thank you for joining. I guess I'll show you what we were doing. We are building the Lego Space Shuttle Enterprise. Right now, we have not built any of this. We have built this tiny little thing right here. It's hard to see with the glare, because I can show it in real life. There. Some of the specifications for Hubble. And we are almost done with Hubble, which is right here. Hope you can see that. And is also up here on this side. So yeah, that's what we're working on. This is the first time I've ever done a live stream, so if the audio stops working or something crazy happens, please let me know so I can try and fix it. But again, I really appreciate everyone being here and asking questions and having a good discussion. And I guess to keep going with the Hubble discussion, yes, just like Arecibo, I think that was an excellent point. We saw that, an excellent piece of technology would just kind of be sat by the wayside and unfortunately, ultimately destroyed due to, not necessarily natural causes, but just wear and tear over time, which is unfortunate. So I think that's just one example of how we could actually preserve some of these incredible instruments. Because like on Mars, the Perseverance rover, the Curiosity rover, Spirit, Opportunity, they're all going to be there. They're going to sit there for a long time. Nothing's going to happen to them except for gradual wear from wind. So, we send people there in the next 100, if we send people to those locations, then they will be there. But things like Hubble, things like anything in low Earth orbit will eventually come back down and be deorbited. Things like the space station. Well, the space station, it's maintained and it won't be deorbited anytime soon, but after end of operation, what will we do? Will we raise it? Will we maintain it? I think it's very important to have these things either to be brought back or to raise them high enough so that we don't have to worry about them re-entering the atmosphere anytime soon. Let me see. I feel like I missed something here. Heat shield also says Hubble should be maintained. Okay, back to Jupiter have water. Does Jupiter have water? Well, Jupiter is a gas giant, so it probably has water in its atmosphere somewhere. I don't know how much it does. I think it's primarily ammonia. It probably has some water, but it doesn't technically have a surface, so we can't really use it that well. Ganymede, which is one of Jupiter's moons, has recently detected that water exists there. Europa and I don't know if is Callisto. I don't know if that has water, but Ganymede does, and Europa do have liquid oceans underneath their surfaces, which are major regions where we want to explore for potential life in the solar system, because a lot of following water is following life. So that's a very, very good question. Does Hubble have engines to raise its orbit? Yes, it does have engines, but not big ones. That's actually something that I'm going to look up really quick, because as you're in low Earth orbit, you need to maintain your orbit, or else over the course of 5 to 10 years, you will deorbit. That's something that even the space station has to do on a regular time frame. But its engines are probably not that large. Let me see. Or potentially, maybe, actually, I think the space shuttle would, I think the space shuttle performed the orbit raising for Hubble. Let me see. Hello. Jose Fernando. I'm not ending the stream yet. No, I'll be going for a little bit while longer. You're playing Kerbal Space Program. That's perfect. Yep, we're just building some Hubble. Just building some Hubble and Enterprise here. Yeah, I think you're right, Kenji. I don't believe it has thrusters to. I think yeah. So I first said that it does have engines, but once I was thinking about it, I don't think it actually does because one of the last Hubble missions was actually raising its orbit, which was very important for the operations. So yeah, as you're saying, you only think that Shuttle could, because there were multiple missions sent up to operate on Hubble and to switch out some of the instruments. So that would mean that yes, we'd have to do that before its orbit decays. Let's see. There's another question. From 42 Mars, Mark, sorry, I'm not pronouncing your name correctly. People think that there are lizard men on Mars. Potentially. I mean, from the pictures we've seen from Perseverance and all the orbiters and anything, I have not seen lizard men, but you know, maybe they're there. I don't know. Well, that's something we'll have to wait and find out. Fun fact, Venus always has a volcano that blows up every single day. I did not know that. That's actually really exciting. I know that Venus is very volcanic. Oh, I know that Io is very volcanically active. I don't know Venus is very volcanically active. I'd imagine, I mean, it's a very hot place. And I think there's still a lot we don't know about Venus. So yeah, so now I guess I should show you all. We finished this part. At least I think we did. We did not. I did not finish this part. I had to put 2 more pieces on this part. 3 more pieces. Now 2 more, and 1 more. All right, here we go. So this is Hubble without the solar panels. That is the mirror inside that had to be fixed. The back with some wires, those wires, and probably opening this for astronauts to operate on the vehicle. And now we're working on solar panels. So, yes, what I'm trying to remember, we were talking about orbit raising for Hubble. Yes, that's very important. So I believe that Shuttle had to do it. I don't think that it has the capability to maintain its orbit. It is in a low Earth orbit though, so that means that soon, not soon like in the next year or two, but probably over the course of a few decades, it will eventually reorbit Earth's atmosphere, if nothing has happened. Actually, I'm going to look that up. When will orbit? Yeah, so it's estimated, again, according to Wikipedia. I don't think NASA has stated anything specifically about Hubble reorbiting. But it's estimated that due to orbital decay, it will re-enter the atmosphere in the 2030 to 2040s timeframe. So yeah, so in the next 2 decades or so, which if we need to do something to either raise the orbit or maintain it, that's going to have to happen pretty soon. I do not know the question, 42 Marcia, who died in space. I do not know. That's a good point, Astro Geek. They can use RCS to keep the orbit, maybe. I believe Hubble primarily uses magnetometers or reaction wheels. That's something I would also need to check really quick. And RCS can definitely do some in raising the orbit, but it will not be able to keep it alive for an incredibly much longer period of time. That could potentially raise it some, but again. And we also have to remember that Hubble is, according, I said this earlier, but it was launched in April 24th of 1990. So Hubble is over 31 years old. There have been multiple missions to update the software or update the instruments on board to maintain some of the vehicles, which is very important, or some of the mirrors. But it's very important to remember that this is a pretty old spacecraft. And, you know, the next major one that is supposed to be its predecessor is the James Webb Space Telescope. So as James Webb is launched, hopefully later this year, I believe it's planned for October of this year, there will be more that has to come about. So you said that there should be Hubble thrust information in the instructions. I don't know if you say that as there is or as it should be included, but I'll check. There is a thing. That's what it's going to look like when it's done, but we are far from there. I don't think it's there. It might be in the beginning. There is not much information about the technical details of Hubble, unfortunately. We can read some of this a little bit later. According to Mars, so where is Hubble? So Hubble is currently in a low Earth orbit. It is, someone said the kilometers earlier, but it is 350 miles, at least at some point. It's 350 miles above the surface of Earth. So this is actually very close to Earth. In comparison to things like the Moon, which are approximately 390,000 kilometers away from Earth, Hubble is essentially right in our backyard. It's just orbiting around us, and if you happen to go out on the right day at the right time, you can actually see Hubble in the night sky with the naked eye. But again, you know, it has to be coming just overhead. Just like the International Space Station, if you go out at the right time and you know the right place and the right way to look, then you can see it. That's okay, Heat Shield. No, I was just curious. I didn't know if you were saying that because you built it before or if it was actually in here. I personally would like to see a lot of the specifications, but you know, a lot of this stuff changes. Actually, I'm really interested in Hubble RCS. So one of the I'm looking this up again, one of the failures on Hubble was a gyroscope, so that did need to be replaced. I actually have another self-plug for one of my videos, but a couple of my videos ago, I did a video about where does space begin, I think was the title, where I go into a pretty detailed discussion about where do we call the boundary of our atmosphere and of outer space. And this is a pretty interesting topic, especially for commercial tourism, so for companies like Blue Origin and Virgin Galactic. But the video goes into where the edge of our atmosphere is and where space begins, and a lot of, and technically speaking, our atmosphere goes very, very far out. The exosphere can go much further than low Earth orbit, in medium Earth orbits, and so on and so forth. So recognizing that Hubble and the space station, International Space Station, and many communication satellites are actually in our atmosphere is why that they gradually deorbit and enter, or gradually deorbit and re-enter Earth's atmosphere. So Hubble, as I said, is basically in our backyard. It's, our neighbor. I forgot to put some pieces on. It's our neighbor in terms of being in space. Now, with that being said, Hubble's predecessor is the James Webb Space Telescope, which is let me see. James Webb is it's been supposed to be launching for a while now, and is currently supposed to be launched in October. I think I said this a little while ago, but James Webb is actually an infrared space telescope. So this means that it looks at a different spectrum of light, the infrared spectrum of light. Now, the problem with the infrared spectrum is that if you've ever seen an infrared detector or an infrared, an infrared camera, you can actually see people, or you can see what the heat that people emit, because humans emit light. We emit infrared light. And like stars emit, like our sun, emit a wide range of light. They emit visible light and gamma and ultraviolet and radio and all sorts of light. The sun is just a major emitter of light. And that is why you do not look at the sun, because it can be blinding, or you put sunscreen on so you don't get, or you can protect your skin. But another important part is that planets can also emit light, and planets emit infrared light. For example, Earth emits infrared light because it naturally has heat, and the planet emits this heat, and it can be in the form of infrared light, which means that we cannot put James Webb close to Earth, or else it'll be basically sitting next to a really bright light. It'd be like putting a telescope right next to like a street lamp or something. You wouldn't really be able to see much. So James Webb is actually going to a place called a Lagrange point, the Earth-Moon Lagrange point 2, or L2 point, which is over 1 million miles or 1 million kilometers away from Earth. But it's in this nice location where it will always kind of stay bounded by Earth, but it's far enough away. And it will use a really large shield, or a sun shield the size of a tennis court, to basically block out all the light from the sun or from the Earth or whatever, and it'll be able to point its major lens, or its lenses, out in towards deep space, and then it can observe infrared light, which can help us actually peer further back in time, or further from Earth, because some of the earlier formation of galaxies and stuff is easier to emit, or the redshift is further in the infrared light. So I know that's a lot of, I don't have a lot of graphics to point to or animations to show, but James Webb is a really interesting project that will definitely give us a lot of insight into future of astrophysics and the development of, how we understand this universe, which is a good point. Heat Shield said, my first serious video will be about where space begins, working on it now. Oh, that's exciting. That's awesome. All right, so it looks like we have completed Hubble. So we have put the 2 solar panels on, like this. We have the shade, the sunshade, right here. And we can also put it on the stand. Let's see, which way do we want to? Let's put it up like that. Yep. There are some extra pieces, but there are no duplicate extra pieces, which make me think that it is complete. Let me put this in my extra piece bag. All right, so here is Hubble. So far, the stream has been a little bit under 2.5 hours, and this is as far we've gotten, so it's definitely taking a while. But we're having some fun discussions, which is good. There is the space telescope. Here's the other side. I think, there we go. There's the name, which is interesting because that's on the bottom of Space Telescope, but is on the top. Well, you would think that'd be on the top, but it's on the bottom when you put the stand down. And we also have, again, this, which is the nameplate. I've done this a bunch of times. Now we can read some of the fun facts about Hubble. Any questions? Heat Shield says, James Webb Space Telescope has to succeed. It's been such an effort so far. I agree, and I think there are a lot of people that are very nervous about it. It not only has to go through a launch, which is generally the most nerve-wracking part of a mission, but it also has to unfurl. Again, I don't have any nice animations to point to, but the James Webb Space Telescope is very much like origami. It is kind of crammed up into this tiny fairing, which once it's released, it'll spend a couple months gradually opening up its lens, opening up the sun sheet or the sun shield, and making sure that every component is right, because this intricate opening is crucial to actually getting data. It's a very sensitive vehicle, and if one part of it goes awry, then that can be challenging or a big problem for the success of the mission. Which means that if it's actually launched this October, which I say actually because it's supposed to launch for a while now, but if it does launch this October, then there's going to be a few months where a lot of people are holding their breath in terms of its success. All right, so the fun fact that's on this page, I know we read the one earlier. The Hubble Space Telescope is responsible for the deepest images of the universe ever recorded, which contains some galaxies over 13 billion light years away. So again, Hubble, with its ultra deep field, being able to get incredible images of galaxies far, far away. How we watch Star Wars is through Hubble. All right, let's read a couple of these other ones. It's interesting. We can read the deployment of it later. I want to see if there's any more fun facts about. Talking about SpaceX, there's a picture of a Falcon 9 in this book, which is exciting. Hubble Space Telescope. The Hubble Space Telescope was created in a collaboration with NASA and the European partner, the European Space Agency, or ESA. From its vantage point, approximately 342 miles or 550 kilometers, I should have read this at the beginning, above the Earth, the 13.2 meter or 43.5 foot long and 14 feet or 4.2 meter wide telescope can detect light with its eyes, currently over 200 times sharper than the best ground-based telescopes. So since Hubble is out of a large fraction of our atmosphere, it can detect some pretty remarkable things from low Earth orbit. Hubble's mission was to spend at least 15 years probing the farthest and faintest reaches of the cosmos. Thanks to 5 space shuttle servicing missions that took place between 1993 and 2009, it far exceeded this goal, operating and observing the universe for over 30 years. During its time in orbit, the telescope has taken more than 1.4 million observations, and astronomers have used that data to publish more than 17,000 scientific publications on a broad range of topics. So Hubble truly is a state-of-the-art telescope, being one of the forefronts in the development of astrophysics or astronomy, understanding so much about how our universe works, the history of our universe, and what we can learn from other stars and solar systems, or stellar systems. Very exciting. So here is Lego Hubble and its solar panels. I will set that down right here. And we will probably be going for a little bit while longer, so I guess I can go ahead and get started with the bigger build, which is Space Shuttle Discovery. So the shuttle program was driven. Let me read this. The shuttle program was driven by the need for reusable spacecraft that could carry large payloads into orbit. Discovery was NASA's third orbital vehicle in the fleet, joining in November of 1983. It would go on to complete 39 missions, fly 149 million miles, or 238 million kilometers, and complete 5,830 orbits of Earth and spend almost 365 days in space throughout its 27 years of service. The 5-day mission to deploy Hubble launched from NASA's Kennedy Space Center on April 24th of 1990. The designers created the telescope to fit snugly inside the shuttle's cargo bay. So here is a picture of the space shuttle landing, because it does not take off like that. That'd be cool if it did, but it does not. Or it did not, I should say. So I will actually put this right here. You can see Hubble. Awesome. Awesome, awesome, awesome. Okay, so this next part is bag 4 and that piece. So let me find bag 4. I think I might have put it on the ground, or I might have put it over here. That's 14, 17, 13. Here's this big piece. No one told me that bag 4 was right here. Can't forget a piece. And now we will be building the space shuttle. First, we gotta put the sticker on. You know, I don't know if I've done a single video about Hubble or the space shuttle. I'm just now realizing that, which is pretty remarkable. For good luck, take one piece with your eyes closed and throw it over your shoulder. I think that's salt. I don't want to be losing any pieces. I already almost lost some earlier. Let's see. Let's see. Oh, there's a whole nother bag I didn't open. That's why I couldn't find this piece. Hmm. Let's see if I put this on upside down. I don't think I did. So you can't really tell. Huh. I think I did. There is the space shuttle. Hello, fun time, fun time. Well, I'm trying to figure out how to make that straight. There we go. Wingspan of 38 feet, or the meters are probably in the book. 1984 to 2011. I'm doing well. I'm building the, I guess I can show again, the space shuttle, the Space Shuttle Enterprise. Sorry, Discovery. I think I said Enterprise twice now. Space Shuttle Discovery. I talk about Space Shuttle Enterprise in the most recent video, another self-plug. There we go. We already finished Hubble, which I think it might be easier to see from this angle. I think it's kind of hard to show it, but I guess I've already finished it, so I can show it off. Yep, so we've been building Space Shuttle Discovery as well as the Hubble Space Telescope. Just finished Hubble, and we're barely starting the shuttle. So this is definitely not going to be finished today. Probably going to be doing this for just a little bit longer. But tomorrow I will pick up and answer some more questions. Heat Shield, Scott Manley, and Simon Dave both did live streams on this. That'd be excellent. Yeah, I mean, this definitely is going to be done today, or probably in even another session. But that'd be awesome to be in a playlist. I had no idea that they also built these. You ever plan on making a video about everything that SpaceX is doing with Starship and Boca Chica? And just like your new series, you should do something similar but with the Soviet Union. Oh, that's an excellent point. So your first point, you ever plan on making a video with everything SpaceX is doing in Boca Chica? Yes, so occasionally, very rarely, once in a blue moon, meaning I think I've done it twice in the last couple of years, I have made videos about what SpaceX is doing in Boca Chica. I think one of the big parts is that there's a lot of really great creators that are making content about Boca Chica and the developments and how rapid it is. And almost every single time I make one of those videos, I think it goes a week or two until most of the information is out of date or something is completely changed and the design changes, which is remarkable because they're just developing it so quickly. But then if someone new stumbles upon the video, then they are already out of date. And I think that's why a lot of these other channels which focus on it, focus primarily on it, are able to give people updates, is because, if they give a weekly update on what's going on, then that's enough for, a 30-minute video all in itself. Whereas where I usually like to give more general views or general or wider range of perspectives, not wider range of perspectives, I say more broad overview of what's going on, then for that case, usually it takes a little bit longer for it to be updated, or for enough to kind of be concrete in order for me to make a video on it. But I have tons of ideas and videos and concepts that I would love to do videos on, and Boca Chica is definitely one of those. Like I said, there's just so much happening there that it's hard to keep up. Even someone that loves to follow this stuff, it's hard to know everything that's going on there. And it says not receiving enough video to maintain smooth screening. I hope that everything is smooth right now. Getting some interesting error. But I can't really tell. If you're having a trouble seeing it, or if it looks choppy, or if I sound choppy, let me know so I can maybe make some changes. I don't really know how to change it, but we'll see. So to your second question, Do you want to do a series like that, similar but with the Soviet Union? I would be very interested in, yes. So I have made some videos in the past, not specifically looking through the variation or the accomplishments from the Soviet Union or from Roscosmos, but I have also looked at kind of the development of lunar and Mars exploration. So this was a while ago. I think this was actually 2 summers ago, but I made a series of videos about a lot of the early missions to the moon, not necessarily Apollo, but some of the Ranger and Surveyor and the Luna missions, and what all those meant and how those played a role in the larger scheme of the Apollo program and the space race and everything. So I would highly recommend you go check those out. But yes, that's an excellent suggestion. I will definitely look into kind of doing a year by year basis for that one as well. But I hope you enjoyed the video I made today. I definitely enjoyed making it. And that's awesome. Okay, everything's fine. Okay, that's good to know. I'm glad that I didn't just completely freeze there for a few minutes. Hello, Warren, I think. Thank you for joining. We are currently working on Space Shuttle Discovery, and we have finished Hubble. This is, I say working on Space Shuttle Discovery, but I'm pretty sure this is just the stand for Space Shuttle Discovery, so we'll see how well that goes. The video you made was actually great. Oh, that's awesome. Thank you. I'm glad that you enjoyed it. It was actually really exciting to make. And a lot of those years, I kind of mentioned in the video, but a lot of those years, there was, it was hard to decipher or to pick which one I actually wanted to talk about. Because during that time frame in the 60s, there's just so much that happened. And even going into the 70s, there was so much that happened, launches and rendezvous and preparations for Apollo and missions that would go out to the outer solar system, that it was hard to really pick the ones that would be considered, the major accomplishment for that year, air quotes, major accomplishment, because there were a lot of major accomplishments across all bunch of different programs. And again, that's still only focused on space exploration, not even talking about the aviation aspect of it. So it was in some cases it was tough. There would be like 3 or 4 things that I wanted to select, but for that case, I ended up just picking some of the ones that I thought would kind of tied in very well with what was going on. But thank you for watching. I'm glad that you enjoyed it. For those of you that haven't watched it, I did release another video earlier today, which talks about the greatest accomplishments of NASA for the first 20 years. So we go on a year-by-year basis, talking about which, from 1958 all the way to 1977, for each year, what was NASA's major event, or what was one of the biggest events that kind of helped play a role in what we know of NASA today. So if you haven't seen it, I highly recommend it, also because it was my video and I'm biased, but I really enjoy it. Really enjoyed making it. Dan did the Lego ISS. Oh, the Lego ISS is also awesome. I built that one as well. I did not do a live stream about it, which maybe I should have, but I definitely love the Lego ISS too. The space shuttle is much quicker to build in that one than it is in this one. And you've never seen a live before. Well, that's an excellent point, because I've never done a live stream before. This is my first live stream. So I thank you for joining, and if you have any feedback or suggestions or want to see some other kinds of live streams, let me know. I know some people have mentioned doing launch live streams as well, but we'll just have to see what launches come up and what people would be interested in learning about. Whoops. Trying to put this piece on. Does not want to cooperate. Whoops. I also forgot another piece. Oh, maybe I didn't. Oh, no, I did. Currently working on what I believe is the stand shuttle. Not necessarily sure what these are. Let's see, what did... I'm not sure if I'm pronouncing that right now. Gwern? Videos on SpaceX are trending right now if you want to grow your channel even more. Yeah, there's a lot of really great videos on SpaceX. I mean, they're doing an excellent job with a multitude of their programs. I love so much about space, all the different aspects of it, whether it be, you know, launch providers, whether it be SpaceX's reusability, whether it be the improvements down at Boca Chica, and there's also so much more, you know, in terms of planetary science, some of the exploration, perseverance and ingenuity on Mars, curiosity on Mars. I also don't think I've ever made a video explicitly about curiosity, which I cannot believe that's possible, but I don't think I have, except for maybe one really early on. But there's just so much fascinating stuff in space that I think there's a lot of really excellent channels that cover SpaceX, and I do love to include them in some of the topics. I actually have a video series, a 5-part series about the history of SpaceX that I made back in 2018 or 2019, which I think definitely needs some updating. So maybe that's something that I'll look into in the near future. But there's a lot to keep up with. SpaceX is doing things so fast. They of themselves are, you know, you got to be on your toes to make sure you know what they're working on or what changes they're making. Is NASA planning on going to one of Saturn's moons, or have I dreamed that? Well, you may have dreamed it, but they do plan on having a mission. It's called Dragonfly. It's not supposed to launch until either the late 2020s or the early 2030s, so it's very early in this design and development stage. But they do plan on sending this Dragonfly mission, which is a quad, or it's an octocopter, I believe. It's either 6 or 8. It's basically like a quadcopter or like a drone, but it has 6 or 8 actual blades. And it will be flying through one of Saturn's moons called Triton. Now, Triton has is a very interesting moon because it has liquid oceans or liquid lakes of methane, because the planet is so cold, but also the atmosphere is large enough that we can actually fly on Triton. So it gives us a lot of, you know, it's pretty interesting because, first of all, we've never been to Triton, or we've never, you know, been able to fly around on Triton. But it'll also be just, you know, kind of this completely unique foreign world to explore that not only will we be able to go there, but we'll be able to fly across the moon, which will be very exciting. But then again, it's going to be quite some time before we go there. I think originally the plan was to launch Triton in the early 2030s, but maybe recently there have been some announcements that it could be, you know, late 2020s, maybe 2029 or so. But again, it just depends on the orientation of, you know, all the planets and how they align and when it goes, when everything's set up right. So there's still a lot more to learn about Triton and how Dragonfly, the mission, is going to fly across the moon of Saturn, but it'll be exciting. It'll be really cool to see that. I mean, just seeing Ingenuity, which is kind of like a technology demonstrator, I mean, it's shown so much success in flying across Mars. And flying on Mars is very difficult. Flying on Triton is, even though it is difficult, the atmosphere is simpler to fly in than on Mars. Reminds me of Avatar. Yes, it will be it'll be Avatar-esque. I think one of the big differences between that and Avatar is the fact that, oh, I put this in backwards, is the fact that it will be very cold on Triton. But it'll be exciting. There we go. There might have been another proposed mission to a moon of Saturn, or it might have been a moon of Neptune, Neptune. That was in one of the recent selections, but it was not selected. That was the Venus missions, Veritas and Da Vinci Plus, were selected to go instead. So yeah. Angie said, yeah, I started following space stuff around mid-2018, so your series on SpaceX really helped me understand what they are doing. After that, I discovered what other companies, agencies are doing in the aerospace industry. Well, that's awesome. Glad that you were able to pick up on some of the early videos that I had and learn about not only SpaceX, but also learn about some of the other companies and all that's going on. I mean, it's very exciting. There's definitely I think, with SpaceX's success and the ability to reuse Falcon 9s, I think there's kind of this epiphany of, well, we can really try a lot of stuff and maybe not everything will work, but a lot of these companies can try different approaches and something might stick. But ultimately, if it's lowering the cost to get things to space, then that's excellent. That's exactly what we want. The lower cost, the more things we can send to space, the more things we can send to space, the more science and exploration that's available. We are working on the stand right now. The stand's starting to come together. See that? So this definitely is where it sits. Not sure what these are still. But I think we're going to grow this out a little bit more on the bottom. For perspective, the Hubble stand is much smaller. So I guess as a side note, something that I think I would personally really like to see, and this is something that I don't know if there's any plans for this. I'm not sure if there would be, because I don't know what the scientific outcomes would be. But something I would really like to see is the Ingenuity helicopter take a picture of the Perseverance rover. There have been so far, as of starting this live stream, I think there have only been 2 pictures taken of Perseverance from Ingenuity, and both of those pictures are either on the corner, the top left corner of the screen where it's very blurry, or the most recent one, which was taken during Flight 11, and it was like pixel. You could barely depict the rover from from the background. I mean, it was still awesome to see it. Don't get me wrong. I love to see those types of pictures. But I think seeing the Perseverance rover from an aerial view on Mars would be pretty incredible, especially from a close-up view. The only challenge with that is that raises a lot of risk because you have this, primary mission, the rover, and you have to fly a technology demonstrating helicopter in close proximity. So maybe keeping it, 50 meters away or so, or 100 feet. But I think it would really be awesome to be able to see such a flight. All right, looks like we are working on the sides of this a little bit more. We are building that out further. We just added these two sides. This main frame right here. I think this stand might be getting close to the end where I will finish today. But I do want to finish this build. I do want to make the space shuttle live, so I'll probably be doing this again tomorrow to keep getting that going, and I don't know if we'll finish it tomorrow, but we'll see how much we can get done. It looks like we're just building out the edges of here, where it still has studs on the edge. We're just covering them up with these smooth surfaces here. One of the most requested events by the public so far. We do have a few, but none are close up and mission labeled. Oh, interesting. Oh yeah, in terms of getting a picture of Ingenuity. Yeah, I think from what I understand, the plan currently is to take samples where Perseverance is now. Hopefully, take some successful samples. Whoop, dropped a piece. Hopefully take some samples near the lake bed and then be able to make its way up to the delta, the river delta, which is where they hope to get some more variety in the samples that Perseverance collects. And currently, Ingenuity is kind of in this middle ground where if it's going to be following Perseverance, it's going to have to backtrack as well. It could definitely fly over regions and doesn't have to stay that close to Perseverance, which means that maybe Perseverance will take the long way and Ingenuity will kind of skip over certain parts. But another part of me hopes that it doesn't, and that it has to go back towards Perseverance, and on its way back, it'll take some bigger pictures. But again, that is something that we will just have to wait and see for the mission as a whole. Whoops. So far, we have had quite a few extra pieces. Here are all the extra pieces we have had. I think I will be finishing up here. So if there's any last questions, I'll take a couple more and then I think I'll probably end it off. But so far today, we have done 69 pages. out of 314. Is this 314 pages? Of course it is. Pi. It's pi pages long. That's awesome. So we've done a pretty decent, a nice amount so far. Finishing up the stand. So as a recap, today we are building, just to finish it off, well, not finish the set, but finish off the stream. We are building Space Shuttle Discovery and Hubble. So far, we have built the stand and the sign for Hubble. Here's the sign. I love to show. It's all pounds and miles. There we go. Yep, pi pages. That's awesome. And Hubble, which was really fun to build. Although at one point I was missing an entire bag and thought it was out of pieces, but that was my fault. And then it comes off the stand, and we have a sign on the bottom there saying NASA. Hubble Spaceflight. Hubble Spaceflight. Hubble Space Telescope. And we built the sign for the Space Shuttle Discovery. And the stand. So, I think that's where we'll end it today. We're going to start on page 70, probably sometime tomorrow. Keep answering questions, keep talking about it, see how it all goes. Probably do a little more research into Hubble and the space shuttle, and we can talk about some of the parts and how it all works. But yeah, if you have any questions, feel free to let me know in the chat or comments in the other video, and I really appreciate it. So thank you. Hope to see you in the next one.